Alright, so today we have polynomial inequalities in two variables, just meaning an x and a y, and systems of inequalities. So there are some reminders for graphing inequalities in case you forgot, so you can read those. This first example is just a polynomial. It's a quadratic, so it's going to be a parabola. And a reminder about how to find the vertex. That's negative b over 2a. That's how you find the x of the vertex. And then plug that value in back into the equation to find the y value. And then the y-intercept, hopefully you remember that from Algebra 1 and Algebra 2, is just the c value, which in this case is negative 8. So we have a negative 2, which is 2, over 2 times 1, which is 2. So that's 1. And then the y value is going to be 1 squared, which is 1, minus 2 times 1, minus 8, which is negative 9. So our vertex is 1, negative 9. So we plot that point. Negative 0, negative 8 is our y-intercept. Now remember, this is a parabola, so we have our line of symmetry. We don't have to write that, but we have a point right across from 0, negative 8 that is symmetrical, so it's right across that line. And so then we can draw a sketch of this, and it's a dashed or dotted line because it is y is greater than, and greater than means we shade above, and always just think about the vertex, shade above the vertex. So that's going to be all of this area right here. Remember, whenever you're shading these, just single polynomial inequalities, you never cross over any of the lines that you graph. All right, so here are two inequalities, a parabola and a line. And that first one is just a parent function. The parent function is y equals x squared. So if we were to graph the parent function of a parabola, we can all do that very easily. Well, notice this one has a 4 and a negative in front of the x squared. So that means it's going to be flipped upside down, and the y-intercept is going to be 4. So we can go up to 4, and it's a solid line because it's equal to y is less than, so that means we're going to be shading below that line. But we don't want to shade that quite yet because we have y is greater than x plus 2 also. So y is greater than x plus 2 is just a line with a y-intercept of 2 and a slope of 1, and that's a dashed line. And we're greater than that line, so that means when we shade, we want to shade below the parabola, but above the line. So that's going to be this section right in here. All right, absolute values. Absolute values might be something that you haven't done in a while. So remember, with absolute values, you're always going to have two answers. So you get the absolute value by itself, then you drop the absolute value symbol, and then if it's greater than, the word in between the two inequalities, or if it's less than, the word in between the two inequalities is an and. So the absolute value of x plus 1 is already isolated, so we can drop the absolute value and say x plus 1 is greater than 2, or x plus 1 is less than negative 2. We drop the symbol, drop the absolute value symbol, flip the inequality symbol, and change the sign. So therefore we have x is greater than 1, or x is less than negative 3. And both those are going to be dashed lines. So we have a dashed line at negative 3, and less than, that's going to be to the left, and then greater than negative 1, that means we're going to shade that to the right. But then we have this y is less than or equal to x to the third plus 2x squared. Well, we just finished graphing those polynomials, so y is less than or equal to, we can pull out an x squared, and that leaves us with x plus 2. So the two places where that cross, we're going to have a bounce and a cut. So we're going to have a bounce at x equals 0 and a cut at x equals negative 2. And it's a solid line, so we're going to cut and then bounce. And there's our graph. Now remember, we're on the outside of each of the vertical lines. Y is less than or equal to, so we're below the cubic equation. So below is going to be this section right down here, and all of this over here. Any of those coordinate points in those shaded areas would make both of those inequalities true. All right, and this is just a compound inequality. Remember, we could separate these two and put them in two different inequalities with the word and. But really, what we're doing on this one is y is going to be equal to, greater than or equal to -5. Y is going to be less than or equal to 2. So we could split that into a compound inequality that said y is less than or equal to 2 and y is greater than or equal to 5. So y equals is just a vertical line. So we have a vertical line at 2, a vertical line at -5. Y is greater than -5, and y is less than -2. So we shade everything in between. Any of those y values in between -5 and 2 would make that true. 0 is less than -2. 0 is greater than or equal to -5. That would make that true.